So on this first word problem in the class opener, as you read it, you should be able to create an equation. It says a class of students with some adults, what I mean by adults, parents and chaperones and teachers, went to the museum. So a total of 36 tickets were purchased. As you can see, there are adult tickets that cost $8 and student tickets that cost $5. The total amount of money spent on tickets was $231. So how many students went on this trip? So we're going to start by creating an equation that deals with the number of items that you're dealing with, right? And right here, we're not talking about items. We're not talking about apples and oranges or nickels and dimes. We're talking about people. We're talking about students and adults. So how many students and adults went on this trip? 36. How do we know that? Because it says that a total of 36 tickets were purchased. So we don't exactly know how many adults or how many students, but we do know that there was a total of 36. So the first equation to make would be that we don't know how many adults. We don't know the A. So we're going to use A for the number of adults. And we don't know the number of students. We're going to use S for students. But we do know that together, the adult tickets plus the number of student tickets is a total of 36 tickets. So we know that that's a true equation based off of the number of tickets that were sold. Now, if we now start talking specifically about money and create an equation specifically about money, it says that an adult ticket costs $8. So I'm going to put $8 times A, because an adult ticket costs $8. See, what that means is if, let's say, 10 adults went, then this would be a 10, which means that there'd be $80 that was spent, right? Because 8 times 10, 10 tickets for $8 each, that's $80. So when it says that each adult ticket costs $8, you better put 8 times each adult ticket, 8A, okay? And then it says each student ticket costs $5, so I'm going to put 5S. And it does say that if I add the amount of money spent on adults with the amount of money spent on student tickets, we're going to get the grand total of $231. Now that is the hard part of word problems, okay? The rest is easy. Why? Because we have calculators in class and we could use those calculators on the day of the test. So let's just now focus in on this system right here. And the system, we need something to cancel. So do you guys want the adults to cancel or the students to cancel? I think it's a little easier to cancel out students because it's a smaller number. If we multiply the top equation by -5, it'll get ready this positive 5s. It'll become a negative 5s, which will cancel with the positive 5s. So let's do that. I'm going to rewrite my top equation right here in black. And with the calculator, -5 times 36 is -180. So there's my new equation. Now the bottom equation, I'm just going to rewrite it. And from there, now I'm ready to combine the lines. I'm ready to eliminate the 5s with the -5s. How about the A's? If I owe 5 and I have 8, I will have 3 of those A's, equaling, let me do this on the calculator, -180 plus 231. That's 51, yeah? So the calculator does all the hard work, guys. Final step would be to get rid of that 3 by dividing by 3, solving that simple one-step equation. And 51 divided by 3 on a calculator is 17. So we know that A equals 17. Now, what is A? Again, remember when we created this first equation, we were talking about the number of adults plus the number of students was a total of 36 tickets, right? So this is saying that the adults are 17 years old. No, I'm just kidding. It's saying that there were 17 adults that went on this trip, okay? So we have 17 adults. How many students are there? How do I figure that out? I simply plug it back in. I'm going to plug it into the top equation, even though you could use this bottom one, but the top one's a lot easier. So let me go with the top one. It says A plus S, that's really 17 plus S equals 36. So subtract 17, and S equals, what is that? 19. So I am not going to write this as a coordinate, and on the test, I don't want you to write it as a coordinate. I want you to answer the question directly. And what is this question really asking for? It says, how many students went on this trip? So what's your answer going to be? 19. And that's it, right? I could have asked how many students and how many adults, but I'm specifically asking for just one of the answers, how many students. Now on the test, I might ask how many adults, right? Or maybe I do ask students, who knows? But be very careful on that last question, which one I'm asking for. I don't want both, I want only the one I'm asking for. So hopefully you guys understood that. Creating an equation based on the number of items that are in your situation, and then creating another equation based on the amount of money that is spent and how much each item cost. So let's use that same concept, that same practice on this next one. Vaughn sells a bag of fruit. Vaughn's very expensive when it comes to fruit, by the way. And inside that bag, there's a total of 12 apples and oranges. Now, we don't know if there's 11 apples and 1 orange, or if there's 6 apples and 6 oranges, who knows? But we do know that each apple costs $1.75 and each orange costs 75 cents. The total cost of the bag is $14. It's a pretty expensive bag. How many oranges are in the bag? So I'm asking specifically how many oranges. So once again, you need to create an equation based on the number of items that you're dealing with, and then another equation based on money, specifically with those items and the total amount of money that's spent. I want to pause it. You guys go for it, then I'll unpause it and explain it. So the first equation is going to be based on the number of items, and we are specifically dealing with apples and oranges. We're not dealing with adult tickets or student tickets. We're not dealing with nickels or dimes, but we're talking about apples and oranges. So I don't know how many apples there are. I want to put an A representing the number of apples. And I know that if I add the apples with the O for oranges, or I'll put OR for oranges, I know that the total is going to be 12. Now, how do I know that? Because it says up here that there's 12 total apples and oranges. Okay. So that is an equation based on the items, on the number of items. Okay. Now, the other equation is based on money. Okay. Second equation is based on money. So, how much does each apple cost? Each apple costs $1.75. So we're going to put 1.75 with an A. And then plus each orange costs 75 cents. So I'm just going to put that as 0.75 with the OR, orange. Okay. Now you guys could use different letters if you want. You don't have to use OR for orange. And then I know that the total amount of money is $14. So I put 14 right there. It tells us that the total is $14 for the bag of fruit. So this is the hardest part of this word problem. It's a system, creating the system. Now once you have this system, we need to solve it. And in order to feel more comfortable with this, you probably want to get rid of the decimals. So you're going to move all decimals 2 spaces over. 2 spaces over, 2 spaces over. Technically, what you're doing is multiplying everything by 100. That'll move all the decimals over 2 spaces. So let me rewrite the bottom equation in red. It's going to be 175A plus 75 oranges. I'll put it as OR. That's not good. It's going to look like 750. Let me keep that yellow, OR, so I don't get confused. And then we have the equal sign. Whoops. And 14 times 100 is 1400. moving over the decimal 2 places, you add 2 zeros to it. That's your new bottom equation. Now the top equation you're going to have to modify in order to cancel out either the apples or the oranges. So I want to go with what I believe is the easier one. I want to cancel out the oranges by multiplying the whole top equation by what? I need it to be a what? A negative 75 to cancel out with a positive 75. So what I want to do is multiply the whole top equation by negative 75. Okay? So when I distribute negative 75 times a, that's negative 75a. Negative 75 times the oranges, that's going to be minus 75 oranges. And then equals, calculator time, negative 75 times 12, that's negative 900. Negative 900. And now it's ready to combine and eliminate. So the negative 75a with the positive 175a, that's going to leave you 100a. And the negative 75 oranges with the positive 75 oranges, those eliminate. And then the equal sign comes down, and 1400 take away 900 is 500. So that simple one-step red equation is solved by dividing by 100, dividing by 100. So your answer is A equals 5. What does that mean? That there's 5 apples in this bag. Now, if there's 5 apples in the bag, think about this. Apples plus oranges is a total of 12. So if there's 5 apples in the bag, let's actually show our work here. 5 apples in the bag plus the oranges equals 12. So the question is, how many oranges are in there? There's going to be 7 in there because you subtract 5. So the oranges equals 7. And what are they asking for specifically? How many oranges are in the bag? So on your answer spot, you just put 7. 7 oranges. Got it? Yay. Now, for today's section, we need to graph inequalities, and we need to graph them. We're going to graph a system of inequalities. That's simply graphing both inequalities on the same XY plane. It gets a little confusing because it gets a little messy, and you need to really represent the overlap piece. But right here, we're just going to do one inequality on each graph. So this equation, it's already ready to graph. It's in y equals mx plus b form. What's your b value? 4. That means that it crosses the y-axis where? 4. It crosses right here at 4. Now from that point, what do I do? I have to look at my slope, right? Now don't just think, well, I'm up here somewhere, so that means I need to go down. Don't think that. Okay, you have to actually look at your slope. And what's your slope, guys?
2.
Your slope is 2. You could put it over 1. So that's a positive 2 over 1, which means that from this point you're going to go up 2. 1, 2. You're off the graph. Over 1. Put a dot out here off the graph. Now, the problem with that is that you're off the graph. So you want to use that same pattern but backwards in order to extend your line the other way. So I would go over 1 this way, down 1, 2. Over 1 this way, down 1, 2, and put a dot right here. And continue to go over 1, down 2, over 1, down 2, over 1, down 2. And that's your line represented on this piece of XY plane. Now, I still need to decide if it's a solid line or a dotted line. What do you guys say? Dotted. Again, remember, if there's a solid line underneath your inequality, that's when it's a solid line. But because there's no solid line, it's not going to be a solid line. So I just put some dots between our coordinates there. And then on top of that, I'm either going to shade in this top part over here or this bottom part over here, depending on where the solutions are at. So the easiest way to go about this is to test the point 0, 0. I want to test 0, 0. If it works, I will be shading in this side, because if it works, it is an answer. That means that all the answers are on this side. If it doesn't work, that means that all my answers are on the other side of the line. Once again, all the answers are either going to be on one side or the other. So when I test the point 0, 0, what that actually means is that you're going to plug in 0 for x and 0 for y and see if it actually works. So when you take the inequality above and you plug in 0 for y, it's going to say 0 is less than 2 times 0 for x plus 4. That's really going to say 0 is less than 4. Now what do you guys think about that? Is 0 less than 4? Yes, it is. So what does that mean? That means at this point it is an answer. That means that all your answers are over here on this side. So the shading is going to be like this. Now, I don't want you to get super crazy with the shading. I actually want nice straight lines from your red line that way. Okay? Now let's practice on the other one. The other one's also ready to graph. That one crosses at 1 because it's y equals mx plus b. The b value is 1. The m value is 1 over 1. We might want to just write that in. The slope is 1 over 1, and the b value is 1. So we know that it does cross the y-axis at 1. Put a dot right there. Now from that point, you go up 1 over 1. So from here, you go up 1 over 1 and put a dot right there. So you continue to put up 1 over 1, up 1 over 1. You could even go backwards, down 1 over 1 the opposite way. And you have the line as long as you want. Now when you're shading, you do want to go all the way from one side of your graph to the other. And there it is. Now this one will be a solid line because it does have a solid line underneath the inequality. So let's actually draw that solid line right there. Put some arrows on it. And now we either need to shade in this top part or this bottom part, depending where our answers are at. So again, the easiest point to test is 0, 0. You don't have to test 0, 0. You could pick any point you want. But what we do want to know is that all of our answers are either going to be on one side or the other. So when I test 0 for x and 0 for y, if it works, then it is a solution. If it doesn't work, that means that the solutions are on the other side of this red line. So let me plug in 0 for x and 0 for y. It's going to say 0 is greater than or equal to 0 plus 1. So if I simplify that, it's just going to say 0 is greater than or equal to 1. What do you guys think about that? 0 is not greater than or equal to 1. No way. So what do we know about that coordinate 0, 0? It does not work. So where are my answers at? On the other side. So you just, like I said, I like to do straight lines from that red line. Don't get all crazy with the shading. Don't do that. Just do straight lines. Whoops. Okay, I messed that up. You guys get the idea. Just do straight lines.